Greetings, boys and girls. In today's video, we are going to be reviewing equivalent fractions. Okay? And so these are things that we've already gone over before, but we just want to keep all this content fresh, and we just want to understand how we may be tested with this particular content. All right. In today's video, I'm going to actually have a couple of jokes, 3 to be exact, and our first joke is this one. What creature is smarter than a talking parrot? Anybody think they know? A spelling bee! All right, so that was our joke as we get ready to start, and now we're going to get right into the review content. Okay, here we're asked to write 2 equivalent fractions. Now, anytime I want to make an equivalent fraction, I am going to take my fraction, my numerator and my denominator, and I'm going to do the same thing to them. So either I'm going to multiply the numerator and denominator by a particular number, or I can divide both the numerator and denominator by a particular number. So I'm going to take 2/5 and I'm going to multiply it by 3/3. Okay, so 2 times 3 is 6, 5 times 3 is 15. So one equivalent fraction for 2/5 would be 6/15. I'm going to take 2/5 and now I'm going to multiply it by another number. Let me go with a 20. So I'm multiplying 2/5 by 20/20. And that gives me 2 times 20, which is 40, over 5 times 20, which is 100. So 40/100 is also equivalent to 2/5. Okay, I want you to take a moment and do 1/3. Make equivalent fractions for that one. Okay, I hope you had a chance to do that. I came up with, for mine, 10/30 and 4/12. Now, you may have come up with some different ones, which is also great. Okay, if you still need some time to figure this out, go ahead and press pause on the video. Otherwise, we're going to move to the next section. Now, we're given 2 fractions, and we have to say if they're equivalent or if they're not equivalent. We're going to either write the equal sign or the not equal sign. All right? So when I'm looking at 2/3 and I'm trying to see if it's equivalent to 4/12, what I want to do is I want to multiply 2/3 times something over something. That's going to give me 4/12. Okay? So I know 2 times 2 would equal 4. And so then, therefore, I would multiply 3 times 2, and that should give me 12. But guess what, you guys? It gives me 6. 3 times 2 is 6. And so because I was not able to multiply 2/3 by 2/2, I know that 2/3 and 4/12 are not equivalent. Now, you could have also proved this by taking 2/3 and multiplying it by 4/4, because you know 3 times 4 equals 12, and then you'd multiply 2 times 4, and that would equal 8. More proof that 2/3 is not equivalent to 4/12. Okay, actually 2/3 is twice as much as 4/12. Okay, let's go ahead and look at 5/6 and 10/12. Same thing. So I want to take my 5/6 and I'm trying to see if I multiply it by the same number, numerator and denominator, I should be able to get to 10/12. So I know 5 times 2 would give me 10. So I have to multiply 6 times 2 as well. And that equals 12. So look, 5/6 is equivalent to 10/12. So I would write my equal to sign in the middle. Okay, let's move on to the next section. Now this time, we're doing a special kind of equivalent fraction. We're reducing this fraction, each of these fractions, into simplest form. When I reduce to simplest form, I'm taking it down. I am going to use the division operation only. I will not multiply to get simplest form, okay? So I'm just trying to think, what is the biggest number that I can divide both a 6 and an 8 by? So if I listed my factors of 6, I would remember 1, 2, 3, and 6. And if I list my factors of 8, I would remember I can get to 8 by multiplying 1 times 8 and 2 times 4. Now I'm looking for the biggest number that both of these numbers have in common. So the largest factor. My greatest common factor is going to be 2. So I'm going to take that 6/8 and now I'm going to divide by my greatest common factor of 2. 6 divided by 2 would be 3. 8 divided by 2 would be 4. So in simplest form, 6/8 is 3/4. Now, something to keep in mind, anytime that you have numbers that are both even, your numerator and denominator are even, you know that you can at least divide by 2, okay? So I hope you have a moment to get that down. I'm going to now look at the next one. In the next one, I have 25/100ths. Now, 25 is not an even number, therefore 2 is not going to be a factor. So I can list my factors of 25. So what numbers do I multiply to get to 25? Well, I know I multiply 1 times 25, and I also know that I multiply 5 times 5. And really, that's all I get for 25. Because 3 is not a factor, 7 is not a factor, 9 is not a factor. So now I'm going to list my factors of 100. Well, I know I'll have 1, 2 times 50. 3 is not going to be a factor. 4. 4 times what equals 25? Well, I can think of this as coins. If 100 is $1, 100 pennies, what coin could I have 4 of to make $1? Well, 4 quarters. And we know that a quarter is 25 cents. Okay? We know 5 would also be a factor, 5 times 20. And 10 is also a factor in here. 10 times 10. Okay, now that I have all of my factors of 100, 1, 2, 4, 5, 10, 20, 25, 50, and 100, I'm now able to look for the largest number they have in common. Now look, they both have a 1 in common. Let's see if there's anything larger they have in common. They don't both have a 2. They don't both have a 4. They also both have a 5 in common. Okay? Let's see if they have anything else in common. Not a 10, not a 20, but look, they both have a 25 in common. So I can take 25/100ths and I can divide it by 25/25. Now, you may have noticed that I stopped looking for the largest number they had in common after I got to 25. And the reason I stopped is because, look, my numerator was a 25, so I'm not going to get any larger than a 25. Okay? So 25 divided by 25 would be 1. And then 100 divided by 25 would be 4. So 25/100ths can be thought of as 1/4. Okay, and why would you do this? If we're thinking about coins, do you want to get 25 pennies out, or would you rather just get one coin to represent that same amount? Well, I would rather just choose that quarter, okay, because I know that 4 quarters makes $1, and if I just have one of them, I have 25 cents, 25 hundredths, okay, or 1/4 of $1. Okay, I'm going to give you a moment to get that down. If you still need time, go ahead and press pause on the video. We're going to go to the next one. Okay, now they're asking us to write the mixed numbers. So we remember a mixed number has a whole number portion, like the 2, and it has the fraction portion, that 1/4. So we're going to take these mixed numbers and we're going to write them as a fraction. Okay, they want us to write it as an improper fraction, or you might call it a fraction that's greater than 1. So let's see if we remember the steps that we take to do this. The first thing I want to do is I want to take my whole number, 2 wholes, and I want to multiply it by my denominator. 2 times 4 equals 8. And then I'm going to add my remaining numerator to that. 8 plus 1 is 9. Therefore, I would write this as 9/4 because my denominator stays the same. Now, you don't have to draw this next visual, but I'm going to draw the visual so that we see it. I'm imagining I have 3 things broken up into fourths. This first one represents 1 whole, so I shade all of those in. Then I have a second whole. I shade all of those in. And then the remaining fraction part was the 1/4. So here's my 2 wholes and my 1/4. Now I could count how many fourths I have to get to the same improper fraction. Now I'm going to go over it with this red. 1, 2, 3, 4, 5, 6, 7, 8, 9 fourths. I just wanted you to visually see how 2 and 1/4 is the same thing as 9 fourths. Okay, let's see if you remember the steps for the next one, 3 2/3. I want you to try and do that one on your own. Remember, you may need to draw a picture to help you visualize it if you're struggling. Okay, I hope you were able to do that. Remember, you would have taken your whole number and multiplied that by your denominator. 3 times 3 is 9. And then to that 9, you would have added 2 from your numerator, which would have given you 11. Now, our denominator does not change when we go from a mixed number to an improper fraction, so you would have had 11/3. Okay, and you could have drawn a visual to help you out. And in your visual, you would have filled in 3 holes and then 2 of the remaining one would have been filled in, not all of them. And then when you added them, you would have had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Again, the visual was not required, but the visual allowed you to see that 3 2/3 is equivalent to 11/3. Okay, we're going to now move on to the next section. If you need to pause this video, go ahead and do so. Now we're going to pretty much go backwards. The last time we started with a mixed number and then converted that into an improper fraction. This time we have the improper fraction and we're going to convert that to a mixed number. Okay, I am going to draw a visual first. Now I'll just do a little box, and my box is going to be divided into sixths. Why did I do sixth? Because that's my denominator. Okay, so I have 1 sixth, 2 sixths, 3 sixths, 4 sixths, 5 sixths, and 6 sixths, and I still have another sixth. So I would draw another box. I was at 6 sixths, so I get to just fill in one more, which would be 7 sixths. So from this visual, I can see that as a mixed number, I would have 1 whole and 1 sixth. Now, how can I do that without a visual? I could use division. 7 sixths is the same thing as 7 divided by 6. And how would I set that up? I'd put 6 on the outside, 7 on the inside. And I would say, how many times does 6 go into 7? Goes in 1 time. Subtract out my 6, so I have 1 left over. So I would be given 1 with a remainder of 1. Now I take the 1 with a remainder of 1 and I turn that into my actual answer. So the number of times it goes in is my whole number. My remainder is my new numerator, which would be 1. And just like before, my denominator stays the exact same. It does not change. So my answer would be 1 and 1 sixth. I showed you that 2 different ways. Now we're going to look at the next one together because I know this sometimes will trick people. You have 14 halves. Okay? If you drew your picture, you would be drawing things that you divided in half. And you would want to have a total of 14 of those. So look, 2 halves, 1 half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, 8 halves, 9 halves, 10 halves, 11 halves, 12 halves, 13 halves, 14 halves. So you would have all of these halves filled in. And once I fill in all of these halves, let's see what I have, how I can represent what I have. Well, that's 1 whole, 2 wholes, 3 wholes, 4 wholes, 5 wholes, 6 wholes, 7 wholes. It would simply be 7 wholes. And when you did your division, you were seeing how many times 2 goes into 14. Well, you knew it went in 7 times evenly. And there was nothing left over. So you just take that, and that's your whole number. You have nothing left over, so it's just 7 wholes. Again, you don't have to do the visual. I just want you all to understand why the answer is what it is. Okay, if you need to still keep working, press pause on the video. Otherwise, we're going to get into joke number 2. What do you call a rabbit with beetles all over it? Y'all, the answer is not gross. Even though it probably would be gross. And it's also not dead, okay? You call it Bugs Bunny. Ha 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 ha. Get it? Bugs are on a bunny. Bugs Bunny. Okay, so now we're going to move on and talk about some word problems. This problem may look very familiar. As a matter of fact, you've seen it. Now, which statement about the fractions 5/10 and 6/12 is true? Answer choice F says these fractions are both greater than 1 because their denominators are greater than their numerators. Well, I know if I have 5 out of 10 pieces, that is not greater than having a whole piece. That's less than a whole thing, okay? So answer choice F is not true. Answer choice G says these fractions are both equal to 1 whole because their denominators are greater than their numerators. No. 10 tenths is equal to 1 whole, and 12 twelfths is equal to 1 whole, but 5 tenths, that's half of that. So that is also not true. Okay, answer choice H says these fractions are equivalent because their denominators are half their numerators. That's an interesting choice. The fractions are equivalent. Well, let's think about it. 5 tenths, I know if I divide them by 5 over 5, I would get 1/2. And then if I take 6 twelfths and I divide that not by 5 over 5, but by 6 over 6, I see that, oh, those fractions are equivalent. So this part is true. These fractions are equivalent. Now, let's see what it says after that. Because their denominators, the bottom number, is half of their numerator. Wait, is 12 half of 6? Or is 6 half of 12? Let's see, 12 is bigger than 6, so it can't be half of 6. So this part is not true. It's really 2 times their numerator. So let's see what answer choice J says. These fractions are equivalent. Yes, we agree with that. Because their denominators are twice their numerators. So let's see. 6 times 2 equals 12. So their denominator is 2 times as big as their numerator. So answer choice J would be correct. Some people chose H for this one. And what I think really happened is they read it and it sounded right because they're like, yeah, they're equivalent. And they didn't read the next answer choice. Because if you would have read J, you might have said, let me go back and read H and see why J is a better choice than H, or why H could be better than J. So make sure that you always read all of the answer choices. Okay, let's move on to the next problem. Last year, Ryan went to school 36 out of 52 weeks. Which fraction is not equivalent to 36 50-seconds? Okay, we've probably seen one similar to this before. What we want to do is, I'm looking at the answer choices. A is smaller, like they would have divided possibly to get there. B, they also would have possibly divided to get there. C, oh, it looks like you would have to do multiplication to get there. And then it looks like to get to D, you also have to divide. So I want to start with the multiplication first because I think that'll be easier. Let's see if 36 50-seconds is equivalent to 72 104ths. So to get from 36 to 72, looks like they just doubled it. So 36 times 2, that is actually 72, and then 52 times 2 would be 104. So look, 72 104ths is equivalent, okay? So now I'm going to try dividing, and I'm going to take my 36 50-seconds, and I'm going to divide it by, let's divide it by 2 over 2. 36 divided by 2 would be 18. 52 divided by 2 is going to be, 50 divided by 2 is 25, so 52 divided by 2 would be 26. So let's see, 18 26. Oh, look, that's an answer choice too. So that's equivalent. I don't want the fractions that are equivalent because they asked me to find what's not equivalent. Okay, now I'm going to look at 9/13. Trying to see if I can get there. So 36 50-seconds. What could I possibly divide 36 by to get to 9? Oh, what about divide it by 4/4? So 36 divided by 4 equals 9, and then 52 divided by 4. Let me do that one on the side. Four goes into 12 3 times. Okay, so now 52 divided by 4 is 13. Oh, look. Right there. B also works. Now, 10/26 has to be wrong. How can I prove that it's wrong? Well, look right here. I said that it's equivalent to 18/26. 18/26 is not going to also work out as 10/26 because the denominator is 26. Okay? So 36 50-seconds is equivalent to 18/26, but it is not equivalent to 10/26. And because that is not equivalent, this is in fact our answer. Okay, let's look at the next one. A teacher bought a bag of clothespins. In the bag, 6/18 of the clothespins are blue. Which fraction is equivalent to the fraction of clothespins that are blue? Now look, all of these fractions have smaller denominators and numerators. So therefore, I know they divided. Now, I'm looking at 6 and 18, and I know I can divide them both by 3, as well as 6 and 2. So I'm going to take 6. 6/18 divided by 6/6 is going to be 1/3. Well, they asked us what is equivalent, and 1/3 is in fact equivalent. That is answer choice J. Okay? I know it can't be 2/3 because I just found this 1/3. And look, my numerator's 1, so it can't be 1/4 or 1/2. Okay. Boys and girls, you're going to do the next two on your own. And you can press pause on the video to do that. The last one we'll talk about together is this one. Edna completed 4 2/3 puzzles. Which improper fraction is equivalent to the number of puzzles she completed? So now I'm just taking this 4 2/3 and I'm just turning it into an improper fraction. So remember, I multiply my whole number, 4 times 3, which equals 12, and then I add to that my numerator, 12 plus 2 equals 14. Now, does my denominator change? No way. So my answer is 14/3. Do I see that answer choice? I sure do. It's answer choice G. Boys and girls, make sure you show your work on this problem. If you still need some time, go ahead and press pause on the video. Otherwise, I'm moving on to the last joke. All right. So why did the banana go to the hospital? Well, it's because she wasn't feeling well. Okay, I hope you guys have enjoyed this video and that it was a good review for you of equivalent fractions. Make sure you show your work, and until we meet again, take care.